Space, the final frontier.
Hi, my name is Kyle Wheeler. Today I'll be talking about interstellar space travel. Space is the last great frontier for mankind, but how are you going to explore it? A couple of great ideas that have been explored by Hollywood's Star Trek and Interstellar are warp drive and wormholes. First of which I'll be talking about warp drive.
Warp drive, Mr. Scott.
The idea behind warp drive is to go faster than the speed of light, which is 3 times 10 to the 8th meters per second. Many scientists believe this is impossible, according to Einstein's theory of relativity, which simply states that an object with mass cannot go as fast or faster than the speed of light. However, there are ways of going faster than the speed of light without breaking this theory. The theory behind how warp speed may work was first made by Miguel Alcubierre. He theorized that faster than light speeds were possible in a way that did not contradict Einstein, by harnessing the expansion and contraction of space itself. An example of this can be seen in this diagram to the left. Space in front of the ship is contracted, while space behind it is expanded, allowing the ship to travel distances in less time than light would take. In the diagram to the right, you can see the ship itself remains in a local region of space, which is between the expansion and contraction waves, in what Alcubierre termed as a warp bubble. And within that bubble, the ship never goes faster than the speed of light. This theory still has its flaws, and it cannot be made possible with today's technology, but it is one of the first steps for mankind to traverse to the outer realms of our galaxy and beyond. Next, we will be talking about another possibility, wormholes. The wormhole is similar to warp drive in that it manipulates space, but instead of contracting and expanding space, it actually folds it. Wormholes also adhere to Einstein's theory of relativity and may allow for more than just space travel. In fact, wormholes may allow for time travel or even travel to other universes. But putting those aside and just focusing on space travel, this is how a wormhole would work. You get a piece of paper, imagine it's space. And you gotta get from one point, this hole on my right, and this other point, this hole on the left. Now you see how long the distances are from one end of the paper to the other. Well, in order to get by this, you fold the paper, or fold space, Fold space, and now the points are almost overlapping. Next spaceship comes in, you can just go straight on through. Now the only difference between this and what would happen in real world is that between these two gates for the wormhole, it would actually be a cylindrical tube going from one gate to the other. And this gate would still be shorter than the actual distance it would take to go from one point to the other in actual space without it being folded. And while the spaceship travels through this tube, it would never be going faster than the speed of light, so it still adheres to Einstein's theory of relativity. Another difference between this example and what would happen in space is that the gates would actually be 3D spheres. And you can see an example of this from the movie Interstellar. As you can see in this video, the spaceship is coming up to the spherical wormhole. After listening to my spiel about wormholes and warp drive, you're probably thinking to yourself, man, that's great. I didn't know we ever knew that much. Man, we got so far. But the fact of the matter is, those are just theories. They haven't been implemented yet, and it may take some time before they can ever be proven and actually used. And that could be another century or a few more centuries after that even. And your next question after that is like, yeah, that's fair enough. Well, what can we do now? How far can we travel right now? Well, to give you an example, we'll look at Alpha Centauri, the nearest star than the Sun. And that is a mere 4.356 light years away. And that's quite a distance. You may think that 4 doesn't mean it's very far. Oh, it's very far. Now, and to give you a reference for that, we'll look at the new probe NASA's building for 2018. They say it'll be able to go 200 kilometers per second, which will be the fastest spaceship ever built. And if we use that number and compare it to 4.356 light years, it would take us 6,547 years to get there. And I don't think I'm going to stay on a ship that long. But don't worry, though. The human race progresses at an alarming rate, and it might have all this within 25 years. So keep your fingers crossed, and thank you for watching my video.